In this section, we'll discuss 802.11ax benefits, industry rollouts, and use cases. People ask, why should I start purchasing and using 11ax when we have very few 11ax clients today and 90% of my devices are 11ac? This was the same question that was asked when 11ac came into the picture, as most of the devices were 11n, with a few being 11ac. There are several reasons to move to 11ax. First, an 11ax AP can serve both 11ax and legacy 11ac or 11n clients, as it is backwards compatible. Manufacturers are starting to make 11ax clients now. For example, Dell has announced it will start shipping 11ax client laptops and other devices by the first quarter or second quarter of 2019. They have said that by the end of 2019, 15 to 30% of everything they ship will be 11ax. This becomes 50 to 60% in 2020 and then 100% in 2021. Other manufacturers will do the same. So over the next several years, there will be a lot of 11ac and 11ax clients. Second, 11ax and legacy clients can coexist just like 11ac and 11n clients today. Third, both 11ax and non-11ax clients benefit. 11ax clients will be more efficient and free up more spectrum for 11ac clients. This is like the carpool lane. The first two lanes are for our 11ax devices. Let's say 50% of the devices are 11ac and 50% are 11ax. I put all the 11ax devices in the carport lane, which makes them work more efficiently, and the remaining 11ac clients benefit because I took half the cars from all the lanes, which frees up contention for the 11ac devices. This gives me higher throughput and performance for my network. The way it will happen is we all know about beacon intervals, which come every 100 milliseconds. The AP will say that I'm going to use my first 40 milliseconds of the beacon interval for 11ax devices and tell all the legacy devices that no one talks for the first 40 milliseconds. These are the two carport lanes. Then I start doing the scheduled access for 11ac devices. They get served, they go to sleep, and vacate the medium, and for the remaining 60% of the time, they don't speak to anyone, so it makes life easier for all types of devices. 11ax uses the fast lanes, and 11ac devices have less clients to contend with, so they're happy, and since I'm doing this more efficiently, I'm giving them more airtime. I have these 11ax technologies of OFDMA and multi-user MIMO, triggered access, BSS color, long OFDM symbol, and 1024 QAM that I serve my 11ax clients with in a much more efficient way, which clears up airtime for the legacy devices. 802.11ax will roll out in waves similar to 802.11ac. The exact feature split is not yet clear, due largely to wrangling in the Wi-Fi alliance among various vendors. Wave 2 certification will occur 1 to 2 years after Wave 1 certification. Here is a short table showing Wave 1 and Wave 2 expected features. Wave 1 will include downlink and uplink OFDMA, downlink multi-user MIMO, target wake time, and hopefully the FCC finalization. Wave 2 will include uplink multi-user MIMO, spatial reuse using BSS coloring, 160 MHz, and 6 GHz. The FCC is still working on finalizing the release of the 6 GHz unlicensed spectrum. It will open up 1.2 GHz of unlicensed space in the 5.925 to 7.125 GHz range. Let's take a brief look at the IEEE Wi-Fi Alliance and commercial activities. Here we see the 11ax timelines for the IEEE specification activity, the Wi-Fi Alliance activity, and some of the commercial activity. The Wi-Fi Alliance certification is expected in mid to late 2019. 802.11ax is due to be publicly ratified and released sometime in late 2019 or early 2020. Devices were presented at CES 2018 that showed a top speed of 11 gigabits per second. In October of 2018, the Wi-Fi Alliance introduced a new consumer-friendly naming convention assigned to generations of Wi-Fi based upon major Wi-Fi technology or PHY releases. 11ax is now referred to as Wi-Fi 6, and 11ac is now referred to as Wi-Fi 5. Commercial activity has already started, with Ruckus and other Wi-Fi companies announcing 11ax APs. 11ax, or Wi-Fi 6, will be a profound change in the Wi-Fi industry. It will bring faster speeds than previous technologies in the 2.4 and 5 GHz bands. Increased range, better performance in environments where many devices compete for bandwidth, and enhanced power efficiency are all characteristics of 11AX. Buckle your seatbelt and get ready for a wild ride. While there are no certifiable clients in the market today, QCOM is bootstrapping the market with chipsets that enable 8-stream sounding. In the access point residential routers carrier gateway markets, announcements are already starting. Here is a list of some of the companies that have already announced 11AX products starting in late 2017 through 2018. Several companies have started shipping 11AX APs as of this recording: Ruckus, Aerohive, and Aruba. As a note, Ruckus was the first to market with the industry's first 8x8 5G plus 4x4 2.4G 11AX access point. The advancements in 802.11ax will benefit a wide range of use cases, but are particularly important for dense environments in which large numbers of users and devices are connecting to the network. Some scenarios that will benefit from advancements in the 11AX standard are large public venues. Stadiums and convention centers are common large public venues that increasingly offer Wi-Fi to improve fan or attendee experiences, increase customer interactions, and create value-added services such as showing instant replays on fan devices or allowing attendees to order food from their seats. Stadiums and convention centers with tens of thousands of users all connecting to the Wi-Fi at the same time pose unique scale and density challenges. The 11AX advancements around OFDMA, 1024 QAM, OBSS coloring, and the faster fire rates will make it easier for large public venue owners to create new business opportunities by offering enhanced services to guests. Transportation hubs. Public transportation stations are also offering public Wi-Fi. Like stadiums, transportation hubs have high densities of people attempting to connect to the network simultaneously. However, these hubs face the unique challenge posed by transient devices that are not connecting to the Wi-Fi network but are still sending management traffic that congest it. The 11AX advancements with OFDMA and BSS coloring provide the tools to manage the challenge with these dense environments. IoT and smart city deployments. These deployments face a wide variety of challenges. In some cases, there can be a high volume of devices all attempting to communicate simultaneously, such as at a manufacturing site. In others, a small number of devices could be idle and need to phone home once a day. Power efficiencies in 11AX can enable devices to go into deep sleep mode and turn on their transmitter at predefined intervals to prolong field time without maintenance. Education and MDUs. College and university campuses have high densities of Wi-Fi users in areas such as libraries, auditoriums, lecture halls, student unions, and student housing and MDUs, as well as at graduation and other campus events. Primary K-12 education trends such as video-based learning, one-to-one computing connected classrooms, and IoT are creating an airtime capacity crisis which stresses network reliability. Thanks for taking the time to view this video training course.